Good afternoon, everyone. Welcome to AMD Day 2 of Shaastra 2022 and the fourth lecture of the Shaastra Spotlight Lecture Series presented by MTX Incorporated. Adding to a bigger and better lineup this year, we are extremely honored to have Mr. Massimo Banzi with us for a fireside chat. Mr. Massimo Banzi is the co-founder of Arduino, the extremely popular electronic hardware and software company whose easy-to-use kits are used worldwide. Massimo Banzi is an interaction designer, educator, open source hardware pioneer, and TED speaker. Massimo started the first Fablab in Italy, which led to the creation of Officine Arduino, a Fablab makerspace based in Torino. Mr. Massimo Banzi currently teaches at SUPSI Switzerland and is also a visiting professor at CIID in Copenhagen. He is the author of the best-selling book Getting Started with Arduino, which has sold millions of copies worldwide. Mr. Banzi has also been a relentless advocate for open source technology and software. Thank you so much for joining us, sir.
Thank you very much for your invitation. Good afternoon, everyone.
Without further ado, let us begin the fireside chat. Arduino has a large user base from high school students to sophisticated graduate students. If you had to explain what Arduino is to a middle school student, how would you do it in the simplest possible way?
Well, it's always a challenge, but the general idea is that Arduino it's a family of small computers that are very different from the computer that you use normally that has a screen and a keyboard. It's the brain that you can place inside objects that become intelligent. So if you want to build a robot, if you want to build, for example, an object that can, like a tea kettle that you can control from the internet and all these kind of things, you need a small brain, and Arduino is that. But it's not only the computer, but it's also all the tools that you need to do this. Because again, programming this kind of devices used to be quite complicated. So Arduino tries to make it simple so that as many people as possible can use these technologies so they can put brains inside the objects they imagine.
That is very fascinating, sir. And we have seen that, right? So Arduino today is one of the most popular open source toolkits available. Even here in IIT Madras, it is widely used by the student community for various projects. Could you elaborate on the motivation behind the development of Arduino?
Yeah, so when I started to work with Arduino, on Arduino with some of my friends, I was teaching in this design school in Italy. We were teaching a master's in interaction design. It was one of the first master in interaction design specifically. And my task was teaching people how to use electronics as a creative medium to prototype. So I experimented with a number of different things, but then it's when I met on one hand, I met my colleague David Quartelles, but also there was one of my students called Hernando Barragan who started working on those kind of topics that we kind of evolved all these, concepts. And the idea was how do you build tools that allow people with limited knowledge of electronics and very basic knowledge of programming to be able to use digital electronics creatively, So this, as a professional level, is called embedded development, and it used to be a very complicated, in a way, topic to explain to a large audience. And the work that we did, then we were joined by Tom Igo, David Mellis, so the group of founders, in a way, all were teaching or working in different design schools, and the objective was to build a tool that would really make it simple for a lot of people to just pick up electronics in a few days, in a few weeks, and being able to take ideas and make them into a reality. So that's kind of the development. Then obviously he went out of the school and became a tool that a bunch of other people used. But originally it was designed for like 50 people that were in the building at this Interaction Design Institute Ivrea in the northwest of Italy.
Sir, as you mentioned, it was only meant for around 50 people to use, and it started off as a very small project in your class. But today it has tremendously grown and has become the stepping stone for most people interested in electronics. Could you elaborate on your fascinating journey with Arduino? What hardships did you face during this journey?
Yeah, well, I think every every time you start to try to build something, you always find hardship, and you always have to kind of work for a very long time to before things start to become really, start to really make really happen when people really start to understand what you're doing. Obviously, Arduino started off as a project for a small school, but I was very lucky that one of my friends and co-founder of Arduino was teaching at New York University. So he was teaching at NYU ITP, which was a program that was similar to the school that I was teaching in Italy, but they had a lot more students. And obviously, if you are in New York, you are connected to a larger world. So when the students started to adopt Arduino, obviously the project started to take off and people started to notice it. And also, in a way, at some point, there was this world of this community of makers that was starting to happen, and they sort of slowly adopted Arduino. But so that kind of fueled the next. Also, another big category of people who jumped on Arduino at the very beginning is the community around the processing programming language, which, in a way, it's the biggest inspiration for Arduino. So all of the principles that are behind Arduino, most of the principles come, in a way, are inspired by processing. Obviously, I've noticed with a friend of mine that whenever you work on something and you want to develop it, it takes a number of years before people understand. So, for example, me and my friend decided that it's about 7 years that you have to work on something before people start to notice it completely. And so, obviously, there was a long time where Arduino wasn't really making enough money for us to be able to be paid to work on Arduino. And obviously, there was that was always complicated. That we spent many years where we had to do other jobs and then work on Arduino in parallel. So that one obviously is a bit of a it's hard when you do this kind of when you set up this kind of things. It's complicated, and obviously, we'll we'll touch upon it later. But there are some issues related to open source that opens the technology to a lot of people, but also a lot of people don't understand what open source means. So a lot of people start to take advantage of Arduino without actually really giving anything back to Arduino, the community. So these are some of the challenges that we had to face. So it took us a very long time before Arduino was kind of able to pay us to work on Arduino, and people understood Arduino.
Indeed, sir, indeed. And when you mention about this community of makers, this is in fact one of the hallmarks of Arduino, right? So we have seen this community grown leap and bounds, and we have collaborations and information exchange occurring across the globe. Did you envision such a community when you created Arduino? How do you see this community evolving in the future?
Well, so obviously I didn't. I don't want to be arrogant, and I don't want to, So what I'm trying to say, I don't like the people that say, "Oh yeah, I imagined immediately that it was going to be huge." I think all the people who say that lie. So when I started, and I started with my friends, with David, Tom, we wanted to build something that was useful for people, that could improve people's life, that would be a tool for people. There was no expectation that it was going to be huge. We wanted it to be moderately successful, but we didn't imagine it was going to be huge. Obviously, it came at the right time. It touched the right people. At the very beginning of the Arduino history, the first users were highly creative people. So they were design students, artists, musicians. They started to use it to build beautiful projects. So people started to talk about these beautiful projects, and people started to say, hey, wow, that's a beautiful project. So yeah, I built it with this thing called Arduino. And obviously that created this nice kind of process that in a way Arduino kind of spread like a virus in a way. So, and then it started to intersect other communities now. Even people in university doing scientific research started to use Arduino. We never imagined it would be that kind of tool, but when you make something simple to use, obviously you start to reach quite quite a lot of people. And the community now is pretty large. So if you imagine the Arduino website, which is kind of the main sort of hub for the Arduino community, has 29, more or less 29, 30 million unique users per year. And the number of people who are really, really active in the community is more than a million something people. But the IDE is downloaded by probably something like 7 million people around the world every time we put out a new version. So obviously the community is very large. The community shifts constantly. So at the beginning it was mostly students, then it became makers, then it became also people doing professional applications, researchers. There's a lot of evolutions, and it's at the moment we see more and more people who do professional projects, who work in companies, who work in the industry. They start to use the more modern Arduino technology, which is designed for the industry. They start to adopt this technology for their work. So I think that's one of the interesting evolutions of Arduino.
So this growth is truly fascinating. And you also touched upon in your previous answer about Arduino being an open source company, right? And you personally have been a great advocate for open source technology and have spoken at length about its need. And open source technologies like Arduino and Linux have revolutionized their respective domains. Could you shed light on the role you envision open source technology playing in the future? And do you believe that open source technology will eventually become the norm?
Yeah, so obviously, when I was younger, much younger, um, I was very fascinated by Linux. I started using Linux more or less when it came out, almost when it came out. And although it was kind of, much more complicated to set up than the competing operating systems. I was really fascinated by this idea that people could build this as a collaboration in the open, obviously using the internet as a medium. Because I really like the idea that you could build something that would belong to everyone. So there wouldn't be a case where somebody would try to lock you into a certain position, and then they sort of own you. Now, there's like a larger discussion about the fact that our world now is basically all digital. Everything that we do almost is now mediated with digital technology. I'm pretty sure that right now in a bunch of countries in the world, more people read the news through a phone or a computer than they read on a piece of paper. So these kind of things means that if the technology is in the hand of a few people, obviously they decide how you live your digital life. So obviously you need this technology to be widespread. So I think open source has won in a lot of different places. Um, and a lot of big companies are using open source to build projects, and they are releasing code as open source, which is great, I think. I think one of the limitation of what we have to reflect now as an open source community is that usually when you set something up, it's not that it's going to work forever like that. So you always have to kind of monitor and check and see how the world changes as a reflection of open source. So now we face a number of challenges. For example, in the world of open source software, it's very complicated for a small group of people to build an open source tool that tries to turn itself, for example, into a company, because in a lot of situations you have like very, very big players who take the open source tools, put them on the cloud and charge people, money for it. And the original developers don't get any money. And if they don't get any money, they don't develop the code. And we have also these challenges where, we had horrible bugs that we have to solve, no? And then we realized that practically half of the internet was using an SSL library that was open source, and the people who worked on it only got $200 of donation in a year. Clearly, you cannot have a piece of software that is so fundamental for the whole internet, and the people who work on it don't get any money. Clearly there is a problem that needs to be solved there of how somebody who builds open source protects themselves and the technology from the exploitation done by other people. So that's, in a way, in Arduino, it's kind of a similar problem. Now, Arduino at the moment sustains itself mostly by selling hardware. But the problem is that the original hardware in Arduino is just a small percentage of what the hardware that people use. And so obviously there's a bunch of companies that are making a lot of money by selling Arduino compatible or even copies of Arduino, and they don't contribute anything back to Arduino. So this system cannot function forever. No? So this is a big reflection that we need to have about open source hardware and software. And I think this is the time where we have enough examples of things that have gone wrong so that we can reflect and try to find a solution.
That was an insightful answer into the problems that open source faces and the necessity for open source. Moving on, we have seen that artificial intelligence and machine learning have emerged as the technology of the future. We have seen multiple services that use AI, from self-driving cars to smart assistants. Arduino has also been working with TensorFlow Lite over the years to make machine learning simple enough for anyone to use. By what time frame do you expect Arduino to have sufficient computational power to handle computationally intensive AI/ML tasks?
Well, so one of the interesting things is that we started to work, back in 2014 when we built a product with Intel. They built into the silicon this little sort of a piece of hardware that would accelerate certain type of, let's call them machine learning application. So we started work on that topic back then. And then obviously we collaborated with Google, who adopted some of our hardware for TensorFlow Lite. So we demonstrated that you can build interesting applications using processors that are very tiny. One of the reflections that we have to have, if you look at, for example, the history of artificial intelligence and machine learning, people have been building amazing things 30 years ago with computers that were, the power of a current Arduino. Obviously, a lot of people, when they think about Arduino, they think about the 8-bit classic Arduino, but the current Arduino boards are 32-bit machines that go up to 64 400 megahertz Cortex M7. So you have enough computing power that you can start to do computer vision, that you can start to do voice recognition, that you can start to do a number of things in a small device powered by a battery, which has a ton of different advantages. And also, AI researchers have realized that sometimes when they simplify the machine learning models from the big TensorFlow models to kind of the lightware version for TensorFlow Lite, even reducing dramatically the complexity, the precision that you lose is not huge. And these models are still incredibly useful, but they work with a fraction of the power, and they use the advances that now the Arduino Portenta H7, it's a dual core Cortex M7, Cortex M4 processor that can do insane machine learning tasks that you would need, a much larger computer a few years ago, and it runs on a battery. So these are the kind of things that is very interesting for me to explore. How you take this massive algorithm and you simplify just enough that they are still very useful, but they use a lot less resources.
Yes, sir.
So
That
the
was
question, the answer is Arduino already manages computationally intensive AI ML tasks.
that was fascinating to know, sir. And as I meant, you've had the privilege of being a member of both the industry and the academia. How was the switch between the two domains, and what unique skill sets did each domain provide?
So in a way, I'm lucky because in a way the kind of academia that I work in is a little bit different than the classic academia. So for example, we rarely write academic papers. So our work is mostly based on building projects to demonstrate things, to explore different directions. So in a way, it's much easier for me to move from one. So it's in a way, let's put it this way, slightly less about the theoretical aspects and more about exploring different directions. So one of the things I think is interesting is we build tools that people use sometimes to learn about technology. So working with students is incredibly useful. For example, I just did a class for CIID that the school in Copenhagen, and I was teaching my students about IoT and the cloud using the Arduino cloud. And then when I came back from the class, I had, pages of notes of things that I saw people couldn't really do because there was some things in the interface that wasn't perfect. So this kind of using this, working with the students is great for exploring new territories, exploring new ideas, looking at what people are fascinated about, and trying to transfer those ideas into some of the products that you do. And then you can actually use those tools in the teaching. So I think normally there's like a loop for me. I kind of work on tools that I use in academia, and then in academia inspires idea for tools, and it just loops like that.
That was fascinating. And of course, we've had an elaborate explanation on Arduino and open source technology. But what do you think it would have meant for Arduino and its future had it been a traditional closed source project?
I would have made a lot more money probably. I mean, at the end of the day, uh, when we started working on Arduino, open source seems like we used a lot of open source tools to build Arduino. So it made only sense to make Arduino available. The thing that was kind of new that very few people have done formally before was open source hardware, so sharing the hardware. So I would say that the big problem in a way with open source is the fact that people either don't understand or you know or they pretend that they don't understand the licenses. So one of the big problems is when people take what you do and they use it in products. They make other products that are based on your work, and they don't contribute back. So I think that's kind of the limitation. So in a way, if Arduino was closed source, clearly it would have been easier to go after some of the people who just take and never give back anything. And you understand that if in an open source community, at the beginning, when a community is small, there is a big interchange of people exchanging value between them. But as the community becomes really big, the number of people who contribute and the number of people who take becomes really imbalanced. And if the number of people who take and never give back becomes too big, you kind of lose. So in a way, I think Raspberry Pi demonstrates that you can be closed source and people will still think that you are nice. So I don't know. I think probably if Arduino was closed source, it would have been easier to generate, in a way, money from it that would support the development that we do. But it was an interesting, through open source we helped a ton of people understand electronics, understand how to build. devices. So, I'm okay with what happened in the end.
Yes, sir. Now we have a representative from MTX Incorporated who would like to ask Mr. Banzi a couple of questions as part of the fireside chat. MTX Global Incorporated is a global technology consulting firm powered by MavQ AI platform. MTX improves decision making for organizations with speed and quality by leveraging MavQ and partnering with other lead cloud technologies such as Amazon Web Services, Google Cloud, and Salesforce. With innovation and service at the core of MTX's DNA, the company helps transform organizations' long term strategy with outcomes in mind surrounding happiness, health, and the economy. In the past year, MTX grew exponentially, expanding from 300 to now over 1,300 family members worldwide. MTX is headquartered in Frisco, Texas, with corporate offices in Hyderabad, Jaipur, the United States, Canada, and Australia. Globally, MTX delivers public sector solutions and transformation projects in healthcare, emergency services, workforce development, public safety, education, transportation, and cybersecurity. Today, we would have Mr. Hridul Gupta, Vice President Innovation at MavQ from MTX, who would like to ask a few questions. Over to you, sir.
Thank you, Rajagopal, and very, very nice to meet you, Mr. Banzi.
Feature.
I'd like to admit that I have been myself a very, very avid user of Arduino myself. And I can recall back when I was in university, there were several very interesting hardware projects that I actually executed in Arduino. So thank you so much for all your contributions to open source. I'm really inspired by your work.
Thank you.
And I mean, based on your conversation with Rajagopal, I do have one question which actually strikes my mind. It's about IoT, and we can definitely see more and more startups, enterprises, everyone starting to go into um, the IoT industry and provide solutions that connects like the edge networks, right? I wanted to understand from your perspective how you see the future of IoT yourself, and do you think it's going to be more open source hardware driven versus driven by closed source technologies?
Well, thank you for the question. Well, I think obviously I hope is going to be open source hardware. This is obviously my hope. Um, uh, at the end of the day, one of the interesting thing about IoT is that we have this development in one hand of a lot of refinement of all the different connectivity protocols. So now we have more and more efficiency, and we have more and more capabilities at the lower computing and sort of power cost. Also, the processor are becoming cheaper and cheaper and more powerful. So in a lot of IoT projects, the hardware itself is not such an incredible thing that you can't replicate. So, it could be easily done with open source. I think one of the interesting things for me for IoT is that in the future, I believe a lot of IoT will be what somebody calls AIoT. So there will be IoT that it's also running some machine learning algorithms inside. Because as I was mentioning, there are Arduino products that are designed for the industry, that are built to industry standard. They have enough capability to be able to run machine learning algorithms, but they are the size, of a postage stamp, so you can put them anywhere. And I think that is a direction in IoT that I'm very, very interested in. This idea that also you can constantly change the way this device operate, not by changing the software, maybe by changing AI models, for example. And I'm very, very fascinated by the idea that once you have these fleets of devices around the world, if all of them are contributing back to a kind of larger AI system, you can, in a way, help all the devices kind of learn from each other. There are some interesting things you can do, and you can do them with the latest generation of microcontrollers that now cost literally nothing. So, these are some of the amazing directions I see the IoT going to.
Indeed. So, thank you so much for that insight. And I would actually like to also ask, when you were also discussing Raj Gopal, we talked about how do we maintain economic feasibility of open source hardware, and how do we motivate more and more people to contribute to this space. We know that it's a two-way street. Open source hardware is there to use for everyone, and everyone should contribute back as well. So, how do we motivate more and more people? Do you have any insights on that?
I think it's been a very difficult part of our job because, in a way, uh, first of all, I think a lot of people don't understand what open source means. So, for example, I am from Italy originally, and in Italy, a lot of people think that open source means free stuff. They don't think that this means that I take this that you have made, but there is a contract that says that if I do something with it, I have to give you back the improvement I made. That thing in certain cultures, certain people have a hard time understanding this exchange base. They think, oh, free stuff, great. So that's one big cultural thing that we need to work on, but it requires a lot of people who kind of collaborate and spread the right approach to open source. In open source hardware, I think that the big problem is that there are obviously parts of the world where hardware manufacturing is obviously way more efficient, or in a way they can kind of get away with some simplification. Let's put it this way. So obviously they are going to always they're going to always, even if Arduino was an open source, somebody would have copied it anyway, you know, and they would have made money on the copies because there are copies of even of Apple products. So imagine. So I think the problem is always a cultural problem. You need a lot of people that educate people about this idea that open source is an exchange. I build on it, and I give you back. And you take it, you build something, and you give back. If only one person is giving and 10 are taking, it's the system cannot support itself, no? So I think it's a question of introducing people to the culture. So in a way, for example, the universities where this event is taking place are the places where you can talk to young people and explain that there is an immense value, but you have a responsibility. If you decide to be part of that, you have then a responsibility as a citizen of that open source community to give back.
Indeed. Indeed. I think the community has to go a long way into this. Mr. Massimo, one more question that I had. This was more about education and learning. And at least in the open source software side and the software side in general, we see more and more young kids getting into software very early in their educational life cycle. I mean, kids who are probably not even 10 years old are coding. How do you see, how do we effectively teach kids about hardware, and how do we make sure that learning how to make efficient systems using not just software but also the hardware component of it goes back to the kids very early in their life cycle as well? What do you think about it, and is there anything that the Arduino Foundation is working towards?
So in a way, um, with Arduino, I think we demonstrated that it is possible to teach some of the concepts behind electronics, behind software, to very, very young children. So I live in Switzerland, and a couple of years ago, I was on TV with this kid, and this guy learned how to read and write at 6-year-old, and 7-year-old, he was working on Arduino. So, a very motivated child can learn about hardware and software if you simplify a lot, no? If you are able to abstract a lot of the details, people can jump on it, and then they can use that. And in a way, Arduino is designed like an onion, we say sometimes, so because you start from the very outside, and every time you understand, you rip a layer and you go lower level, and then you rip a layer and you go lower level. Obviously, like an onion, every time you rip a layer, you cry, but you know, but you learn, no? And I think that there's an aspect of starting very high level and then kind of going down into the detail. It's with true refinement. It's an important process that we demonstrated can work even with young children. And I think, you know, in Arduino, we're always like super interested to figure out how do we teach more technologies, complex technologies to people. So, for example, you know, teaching AI, it's an interesting topic that I'm working on right now, because at the moment, a lot of the classes that say learn AI in 2 weeks, either the first page is full of formulas, and not everybody has advanced calculus. And in a way, it is described as an academic, in a way, endeavor. While there are ways where you can go back to the basics, learn little simple concepts, and build up the knowledge so that people can gradually understand. So there is a big opportunity and a lot of work to do to take the way you teach about technology and AI and flip it around so that you make it simpler for people to understand.
Indeed. Yes, I think there is a long way to go there, and I'm sure there would be breakthroughs through the Arduino Foundation, and the kids would be working not just on software but hardware as well. Thank you so much, Mr.
Thank
Massimo.
you.
It was
Thank you.
very interesting talking to you, and over to you, Rajagopal.
It was a pleasure. Thank you very much.
Thank you, Mr. Hridal. And as you were explaining, sir, on how the importance of education. So we have the second arm of Arduino's mission Edu. It aims to provide quality education to the next generation. So are there particular initiatives Arduino has taken to enhance STEAM education accessibility in underprivileged areas? And what do you think learning such skills has? What importance do you think that learning such skills has in uplifting these communities?
So in a way, you know, I think one of the things that we did to help people is, in a way, we made everything open source, which allowed people to basically build versions of Arduino for their community. You know, when Arduino launched, for example, we had people in the Latin America that couldn't afford buying an Arduino from Europe. They started making themselves. One of the first people who started using Arduino after we launched it was a professor in India who basically, again, built the PCBs and made the Arduino by hand. So in a way, that approach has lowered the barrier dramatically because you can actually build the tools if you want to. So I think this education is obviously extremely important to me and to Arduino. We even have an entire section of the company that just builds educational tools for schools, for teachers, for students. So there's and also I think for me personally, education is extremely important because one of the it's important that, as I mentioned before, the world right now is digital. Even creative endeavors, if you want to make a movie, if you want to write a poem, whatever, you're going to use some digital tool to do that. So if only a few people have the technology, and then in a way, these few people decides how we live. You know, there are situations where you kind of enter into one of the big ecosystems, and then suddenly that company, you know, is deciding what movies you can watch, what books you can read, you know. So in a way, the tendency is always to kind of lock people, while if a lot of people understand about technology, they can say, okay, this computer, I don't like, I can try to build another computer, or I can try to build the different things, or to the same questions, there are a lot of different answers, and each group of people, each culture, each nation, whatever, can answer differently to those questions. And to me, the openness of technology is fundamental to allow this plurality of ideas, this inclusiveness. So a lot of people have to understand digital technology in order for us to be free. Otherwise, we're going to live in a world that is designed in California and made in China. So I don't think sounds like a great idea for the whole world. No? So I think that's one of the important things.
Indeed, sir. And as it has been proven by the multiple projects and the millions of developers you mentioned in the Arduino community, we have the palm-sized Arduino serving as the electronic brain, runs everything from high schoolers, robots to high-end models. So what do you recommend to those who want to start an Arduino-driven startup?
Well, okay, so it depends on what it means to do an Arduino-driven startup. For example, so in the last few years, Arduino, so also let me explain that Arduino is a company that has an open source community. So before the previous speaker mentioned Arduino Foundation, there is no such thing as the Arduino Foundation. So a lot of people sometimes use that term because there is an Raspberry Pi Foundation. So, but even the Raspberry Pi Foundation is a foundation and a business company. So Arduino is a business. So in a way, we work with the open source community. So in a way, we have made a lot of products in the last few years that are for industrial professional use. So they are designed to be placed safely into equipment. So some startups are taking advantage of that as a way to build products. So they don't build kind of the full device, but they use Arduino as kind of the core, and they might build the service on top of it. So that's one kind of Arduino startup. So I would recommend that they go to the Arduino website and they click on the Pro button. There's a lot of interesting conversation, a lot of interesting products and services over there that are interesting. One of the interesting things about open source is also that since Arduino designs 100% of the hardware that it sells, we can license it differently. So one of the things that is happening right now with companies and startups is that somebody starts from an Arduino product and they build something, and then they say, okay, now I want to build my own product based on your hardware. So we can license them the commercial use of the hardware, so they don't have to make it open source. So this is an interesting. Then there are other people who are making businesses about selling Arduino copies. So what I would recommend is to be very careful the way you use the Arduino name, because everything is open source, but the Arduino name and the names like Uno, Mega, whatever, they are all protected. So in a way, if you want to build a startup which is based on open source hardware like Arduino, you can take advantage of what Arduino makes, but you need to give back. So if you design hardware which is based on Arduino, you need to release the files of your product. If you make changes, improvement to the software, release that, because otherwise we all lose. Because one day Arduino can decide that doesn't want to, that it doesn't make sense to invest energy into something, and we can abandon, part of the products, and then everybody loses. So we need this exchange.
Indeed, sir. It has to be reciprocal. Whatever you take, you have to give back. And I think that is the core of what would drive a good open source community, an excellent open source community, I would add. And finally, is there any message you'd like to give to aspiring project creators in the audience present and the student community of IIT Madras?
Yeah, I mean, you are in a great place in your life right now because you are young, you are exploding with ideas, you have a lot of energy. So, and also you see the future. You have desires, you have dreams. So in a way, you are the people who can think of things that other people cannot, because you can see further in the future. In a way, I guess older people have the experience to navigate slightly better the present, but the people who can dream the future are the younger people. And clearly, since, as I mentioned multiple times, the world is digital, obviously we need people who dream a better digital world. So we need people who are less fascinated by the cult of personality of, my God, Elon Musk, forget about it. You can invent, you can make an impact even on your little community. You can make an impact if you want to, but you need to dream. You need to dream a world where we are, where there is openness and a free exchange of ideas, and a world where we're all, in a way, the same, we're all equal. And so we work every day to make that happen. And you have the advantage that you are young, you are full of ideas, you're full of energy. You need to contribute that energy to dream a future that's better for every one of us. And then you can take some of that energy and maybe turn it into an idea, a product, an association, even like a class to teach, whatever you can do, dream a better future and then build it.
Thank you, Mr. Banzi, for that riveting fireside chat. I think that final answer really inspired all of us. And the importance of having the ability to dream in the first place and converting the dream to a product that can potentially help a lot of people is indeed something that all of us would look forward to and hopefully would come up with products that can benefit the world as a whole. I'm sure that the audience present here also would have learned a lot. We thank Mr. Hridul for joining us on behalf of MTX2. We thank the audience for attending the session. Please fill the feedback form shared in the YouTube chat, which will help us in improving the upcoming sessions. Up next, we have former Chief Justice of India, Honorable Justice R.C. Lahoti, delivering a lecture followed by a Q&A session at 3 p.m. Stay tuned to Shaastra IIT Madras's YouTube channel